Good. Fantastic. Thanks, guys. Welcome, everyone, to the first OpsTalent event of the year. Delighted to see so many people here tonight. I'm really thrilled. Elastic, for all the team coming over. Got them from Germany, Vienna, all over the place, and they're going to tell us all. We're going to learn so much about Elastic and the technology, and please feel welcome to go up and talk to the team, ask them questions. They're here to help out and to learn. My name is Ken Coyne. I'm the head of technology here, guys, at OpsTalent. And I just briefly would like to tell a bit about OpsTalent. And then from there, I'm going to talk about our relationship with Elastic. Don't worry, I won't keep you too long. And then we can move on to the main event. We've got Paul here, which is the Area Vice President of Elastic in Central and Eastern Europe. He's going to talk just a general introduction about Elastic, the company, and a bit about the technology. From there, we're going to move to Philip, who's going to talk about Elasticsearch, and we've got then Piotr, who's going to tell us about machine learning, and then we've got Richard over from London, who's going to tell us a bit about how data practitioners are using Elastic to help companies with their client engagement using artificial intelligence and behavioral science. So going back to OpsTalent. So OpsTalent is a family business. As you might have guessed from my accent, I'm not very Polish. I'm actually Irish. So we're actually an Irish-Polish family business here. So it's myself, my brother Trevor, and his wife Gabriella, and we run the business together. And at OpsTalent, we're like one big family. It's very much about culture and about people, and our OpsTalenters are an extension of that family. First of all, I'd just like to make an announcement to our new member of our management team. So up front here, we've got Martin Ring. So Martin just joined us from Bank of New York Mellon. He's now a non-executive director of our company, and he's going to help us with our strategy and help us build our business. Martin built Bank of New York Mellon from 85 people up to over 1,500 people. And we're really looking forward to having Martin on board to help us build the company for the future. So Martin, just take a small little stand. Little wave. As we say in Irish, Céad Míle Falter, which is 1,000 welcomes. So welcome to the team. Looking forward to working more closely with you this year, Martin. So Elastic. So we've been working with Elastic for a number of years now at OpsTalent, and we love the technology. We've been helping out a number of clients, and we've been building teams of people around just helping clients use the technology. So we wanted to get more into Elastic, and we wanted to create an Elastic ecosystem here at OpsTalent. So what we did is we've actually formed a joint venture with a company called Data Practitioners, which is a leading data company out of London. They're doing data consulting on one side of the business, and on the other side, building a product all around, like I spoke a moment ago, about the client engagement and using artificial intelligence and behavioral science around that. And we're delivering all that technology here in Poland for that. So we're scaling teams at the moment. We've got a mix of different teams now, Elastic specialists, and we're building out consulting teams and helping clients on different solutions. It's an amazing technology, but you do need good partners to deliver the right solutions, and we're out there to build world-class solutions and data practitioners. Now, with data practitioners, we are a partner of Elastic in London and very much so here in Poland. This is our first joint event together, and hopefully the first of many events. Fantastic to see so many people out here tonight. Obviously, a lot of interest in Elastic. And it's an amazing company, to be honest. I mean, the company itself is only 6 years old. I mean, it's got 350 million downloads worldwide. Open source technology. It's 1,300 employees now. And it's just been building from strength to strength. So next, what I want to do is I'd like to introduce Paul. So Paul, like I said, is the VP. He's going to introduce Elastic and tell us a bit more about it, and we'll go from there. So Paul, you got 15, I know you're American, you like to talk, so you got only 15 minutes, okay?
Terrific. Good evening, and there's the clicker, and that means forward. Great, we're all set. So thanks for coming out tonight. Thank you very much for being a part of this event. Elastic is a great technology. We're obviously very proud of it. We also love working with our partners throughout the world because we provide a fantastic platform but we also rely upon a network of partners that help us to put the fit and finish and really add a lot of value to what we provide to give all of our customers and all of our users a more complete solution. So we also are a company that started and continues to build around a core of search. And you saw in that very short video, our CEO and co-founder, Shai Bannon, show some of the examples of companies that put the Elastic software to work and build, as you can see, a very broad range of solutions. And at the core of every one of those solutions is search. That's the DNA. That's, if you will, our secret, not so secret sauce. That's at the beginning, in the middle, and at the end of everything we do. But let's click on the, I can click it here? Is that gonna work? There we go. So we'll do a quick overview right now. Where's the next slide? Did I go the other direction? Let's do that. That's better. So I'm not gonna provide a big product overview. We have technical experts that will spend much of the evening providing you with a technical overview. What I would like to do is tell you a little bit about the open source technology that we've evolved, about the community that's built around it, and some of the customers that use it. So this is the Elastic Stack. And for some of you, you may have heard of it called the ELK or ELK stack. So I just want to get a quick show of hands, everyone in the room, if before tonight, if you've heard of Elastic or ELK, and that is something you've somehow come across in the past. Show of hands? That's quite a few people. Great. Let's go one level deeper. How many of you, therefore, have downloaded this software at some point in time and have had a chance to try it out and experiment a bit with it? That's quite a few of you again. Great. Let's go another step deeper. How many of you have actually built a version of it that you now use in some productive way? Production. That's still quite a few of you here as well. Fantastic. So therefore, when we're talking with you tonight, we're not talking to strangers that know nothing about this. Most of you know something, or many of you know quite a lot. And at the core, what we've done is we've taken a very simple starting point. The core body in the middle is the Elasticsearch platform. And we began, we meaning Shai and 3 other gentlemen that founded the company and helped to create the technology. They built something that was licensed under the Apache 2 license. So the great news is that our core product, which includes now not just Elasticsearch, but Beats, Kibana, and Logstash, so that ELK, or ELK-B we like to say sometimes, that concept is something where anyone can download it and use it at no cost forever. And by the way, this is not the cheap version of it or the bad version, and you have to pay to get the good version. This is it. This is the only version we have. It's free. Use it. Because here's the important thing. By using this software, by touching it, by getting involved with it, by filing a bug report, by putting a pull request on GitHub, you become part of a community, a global community that is over 100,000 strong, of people, of individuals, of companies, of organizations that put Elastic to work in different ways. By showing up here in this room tonight, you are part of our community. So welcome. We're glad you're here. And we hope you get something valuable out of our event tonight. But on top of that, we also have built a company that adds additional value on top. So when we are a product company, we have an open source core product. We have some additional plugins that we sell on a commercial basis. And the good news is we have a lot of companies that want to use these additional components and pay for them. So what we wind up with is a very healthy, very sustainable system, an ecosystem, which starts with the community, which extends into a commercial set of offerings, products, which enable us as a company to pay for more engineers and build more product and have more testing and better documentation and so on. So it's been a very virtuous cycle that has continued for the last 6 years to bring us to the point today where we are extremely confident, extremely excited about our product, extremely optimistic about the future. And I think the thing to show you here with this picture is we start as a platform for search, where you can store, initially, primarily people stored text data. But as the technology began to mature and grow in its use and build a bigger community, we suddenly began to see that companies and individuals were using Elastic to search machine data. And then someone said, well, why don't I put some security data and do security analytics? And somebody else said, why can't I particularly store some business data and provide myself business analytics? And the product continues to expand. For example, when we thought that people would be interested in having a deeper and more accurate look at what's happening with their data to seek anomalies on a more detailed level, we introduced a machine learning capability. Not because machine learning is cool and it's a great new thing and everyone thinks it's very hot and it's exciting. No. Because people said we would like to be able to more accurately find intraday anomalies inside of our data that don't show up on a normal high or low level analysis of what's happening to my logs, my metrics, or any other data. So we've introduced things we think that are what our customers wish to have. They tell us that quite openly. We've introduced things which continue to expand the versatility and range of types of data you can store for new and more interesting outcomes. Last year, we introduced the APM capability into the product. And by virtue of doing that, we've now incorporated, if you will, a new layer, a new type of data source for application performance monitoring data. When put on a dashboard with your metrics data, and on that same dashboard, you have your log data, you can have now 3 pillars of observability that enable you to really dig deep into what's happening so that your DevOps, your developers, your production team can all carefully assess and analyze what's happening in your data center to a high degree of precision, right back to the line of code that you can trace out and find where you have some latency, for example. That's, for us, is really exciting. We continue to expand and plug in and add capabilities that are helping our customers to do more, to get more value. So the last thing I want to show briefly here is something we're extremely proud of, which is a list of customers. A typical chart that has lots of different categorical leaders, organizations, industries. Many of these are in Europe, as you can see. But the important message I want to share here is this. Technology, finance, telecommunications, consumer products, automobiles and transportation, logistics. The interesting thing for us, an exciting thing, is that the users of Elastic, the companies, the organizations, the institutions that deploy Elastic commercially, these are our paid customers, you know? They come from all industries, because all industries use data. All industries are trying to solve problems and get value. All industries have to secure that data and process it in creative ways. And this chart is just a small, tiny snapshot, but one that we feel speaks volumes about the kind of institutions and organizations that today put Elastic to work and get something out of it. So with that, I'd like to switch and hand over the program. We're going to go now to Philip Kren, who is one of our developer advocates. He spends countless days of the year, planes, trains, and automobiles, traversing planet Earth, talking to our communities, talking to our users about creative new ways they can use Elastic. Philip is a terrific guy in terms of his deep knowledge of the product, but also his passion and enthusiasm for our community of users. He's not on the sales team. He gets to do everything except for doing the selling, which he loves, because he leaves the selling to Derek and to me and to a couple of other folks. In fact, real quick before I stop, I'm going to ask briefly the Elastic team that's here tonight Everyone to please stand up for a second. Come on up toward the front so everyone can see who you are. And what I want to encourage all of you to do is to come talk with us. We're nice people. We'd love to have a chat with you during the break, have a beer, have a snack, talk with you after the program is over, but get to know us because we're here on the commercial side, on the open source and community side, on the partner side to support all of you to get value and to get some results out of our software. We're super proud of it. And the other thing I'll say is this. Many of you, most of you raised your hand at some point to say you've used the software, you've heard of it, you've thought about it, or you've deployed it. So what I want to ask all of you to do during the breaks tonight is don't just stand around and look at your phone and check your email, but you're here live. You've made the effort. You've come through a below zero night to hang out with us, but hang out with each other as well. Ask the person you don't know next to you, what are you doing with Elastic? You might discover something really interesting because this is how our community works. We get to know each other, we exchange stories, we discover things. It comes from not just us, but from all of you as well. So we're glad you're here. Take part, make the most of this program, ask a lot of questions, hang out and talk, and we are glad you're here. Thanks a lot.
Thanks a lot. Hi everyone, I'm Philip. I'm part of the engineering team. I will focus more a bit on the internals. Let's see where we can take this. So we've heard the term search many times, and I just wanted to take a step back and see what does search actually mean here? So who is already using databases? I guess that's pretty much everybody, right? I hope so. Who is already using search in the term of full text search? That's just a small percentage. So let's see what full text search is actually, or how it is different and what can be changed from a database to search. I always try to explain it with this. The left-hand side, that is the database. The right-hand side, that is search. Databases are very much about black and white. You store something and then you retrieve exactly what you have stored. Whereas you can see on the right-hand side, you have more these shades of gray, where you probably don't know exactly what you're searching for. Maybe you search for something in the singular or the plural, but you're more interested in concepts. It might not be the colored picture, the reality, but it's closer to this fuzziness that you have in the world. So how do we do that? Obviously with Elasticsearch, and if you're searching on any of these sites, behind the search box, there's always Elasticsearch doing the search for you. If the search on any one of them is not working properly, I would blame it on the implementation. But we can discuss that afterwards. Like I said, I work as a so-called developer advocate, so I don't really work, I just travel and talk and try to know stuff and answer questions. So if you have any, just come to me afterwards. So why are databases so different than search? It's mostly we do more work up front when we store stuff. So there is Apache Lucene down under the hood, which is basically storing stuff on disk. Because every now and then I get the question like, what is the database behind that? Are you using MySQL or Postgres or anything? No, we don't. We have Lucene, which is actually the thing storing the data on disk. And then Elasticsearch is kind of around it. So you interact with Elasticsearch and it provides the REST API, the query DSL, the replication and sharding of your data, but it's what is actually doing the search and writing the data to disk. That is then Apache Lucene in the background. And we're also a heavy contributor to Lucene. So, who remembers Star Wars and what is the sentence when he makes that hand movement? Anybody remember Star Wars? Come on. No, there it's, these are not the droids you're looking for. And this is the one sentence I want to look at, like, what is actually happening when you put that into a search engine? What is it doing with this analysis that is happening up front? So we have, these are not, and you see we have this emphasis tag around not, because maybe it's stress. These are not the droids you're looking for. So what you do is, the first thing you normally do is you throw out any formatting, because nobody is searching for that emphasis tag. You just care about the content. The next thing that you do is you tokenize. Tokenizing is very simple in Western languages. Like Japanese and Chinese is very different, and there it's very complicated. But in Western languages, it's very simple. You have punctuation marks and spaces. There you basically break it up, so it's just words. You can see we have a bit more space between the words. This is like simulating this breaking up. and the dot at the end is gone, because nobody's searching for the dot either. So we have these tokens that we have extracted. Then we lowercase everything, because most of the time, at least when I search on Google, I don't care about upper and lower cases. I just lowercase everything and search. And, well, there is this different ASCII or UTF character behind upper and lowercase, so you would always need to search for all kinds of combinations. You just lowercase it when you store it, and then your search also uses lowercase, and then you don't have to make that differentiation anymore. Then, what you do is you remove the so-called, or you can remove the so-called stop words. So you can see, these are not the droids you are looking for. There are a lot of very common words that are appearing in almost any sentence you have. And they have very little meaning because they're everywhere. So if you're searching for them, you're not going to find much relevant content. So the non-stop words that are remaining here is droids you looking, because these are all stop words because they're so common. And we would just bloat the index and just store a lot of unnecessary data, so that's why we kicked those out. The next thing that we do is we stem. Stemming is basically reducing down to the root of the word, which in English is very simple. From my very basic understanding of Polish, it's much harder. But in English, you can see droid, droids. We don't care about singular or plural. We just stem it down to the word root. So you can see droid, you, and then look, looks, looking. It's all the same. You search for the concept. So we stem down to these concepts. So this is the analysis part. And you can actually try that out hands-on. So if you've never seen Kibana, this is Kibana, and we have the so-called console where you can just run queries and try them out. So here we have this sentence that we've just talked about. So these are not the droids you're looking for. I'm using the English analyzer, and I don't store anything. I just throw it against this underscore analyze endpoint, and I basically try out what would happen if I would store that in Elasticsearch. So if I run that, you can see we extract droid, you, look. And you can also see we have like the start and the end offset. That could be, for example, very handy if you want to highlight the hit. If you have a very long text and you want to see where is my actual hit, then you can mark that. And you also have positions. You can see this was the 4th word, this was the 5th word. This will come in very handy if you do a phrase search, where you say this word followed by this word. By extracting those, it will be very efficient to search that. You can also define that entire pipeline here, or analysis pipeline that I've described, like you see here. We throw out the HTML, we use the standard tokenizer, we lowercase everything, we remove the stop words, we use the snowball stemmer, and this is the sentence that we're looking or trying it out on. So once I run that, you get exactly the same result. So you can see this is just what would happen if we store that. And this is happening up front. And this is kind of like the additional work that we put in. And this is what will make the search afterwards so efficient. So we have covered those. Something that people are sometimes confused about is like, how many stop words are there? It's very well hidden in the source code, but the list in English is pretty short. So you can see these are just the stop words. They are not that many, and they just happen to be so many in that sentence. These are not the droids you're looking for that we tried out. Should you always use stop words? Any guesses? Anybody for yes? Anybody for no? Anybody for it depends? Because it depends is normally the answer we always give, because as soon as you have like a more complex scenario, it really always depends. And it does. For example, take this one here. These are all stop words. Like you would never find Shakespeare's works if you just throw away all the stop words, because they're all gone. So you might need to consider whatever makes sense for your use case. These are all the languages that we support out of the box. Which one is missing? Polish, unfortunately. We'll get back to that in a moment, don't worry. One other thing is, all the rules are always very language dependent. For example, you can see in English you have this is, has, or the possessive apostrophe s. That's generally stemmed away because not much meaning to that. In French, you might have the article in the beginning or an accent, and it doesn't make much difference either. So we throw that away. In German, we have these weird umlauts, and that special S thing doesn't have much meaning either. We just kick those out and kind of normalize it. So there are more plugins to analyze, for example, Asian languages. But, for example, since I mentioned Polish is kind of a complicated language, there is a plugin called Stempel that does the Polish analysis and stemming for you. And you can actually try that out. So I think that is kind of the same sentence, more or less. Yes, you kind of agree? Okay. I won't try to pronounce it because I will fail miserably, but you all know what it means and how to pronounce it. Any guesses what will remain if I run that through my pipeline to analyze it? So here, let's say we have our Polish phrase here. We're using the Polish analyzer. What will remain? Any guesses? Just two words, droid and some other word. And I hope that kind of makes sense for you. I don't really know, but this is what would remain here. One other thing you need to be careful about is if you use English on a Polish text, what do you think will happen? Nothing good. Because, well, it's trying to apply the English rules. So, for example, this is like the English 2. This is just a stop word and it's just thrown away. And otherwise, it tries to use English stemming rules, but those don't make much sense. Okay, let's take another example. Let's take the sentence, Obi-Wan never told you what happened to your father. And let's use it in English again so I can participate here. What will remain if I run that through this same analysis pipeline? Which words will remain? Any guesses? Obi-Wan. So what you will get is Obi-Wan never told you what happened your father. In this case, we don't have that many stop words, but it's just pure coincidence. And you will also see one other thing, for example, this is not dictionary-based. This is really just rule-based. For example, told, you might assume that it should be reduced down to tell, because that would be kind of the base form. But it's not dictionary-based, it's just rule-based, and we don't have a rule to actually catch that told, that irregular verb. So it will stay told. And you will not find that if you search for tell. Let's take another one. No, I am your father. What will remain from no, I am your father? It will actually be, I am your father. And that's showing you one other nice thing or interesting thing, because that might be a misconception. No is actually a stop word. And this is not like natural language processing that understands your sentence. Because no often makes a difference, is it or is it not? But we don't do natural language processing. We don't understand your sentence. We just extract the tokens and then work on the tokens. So it's not like parsing, like sentiment analysis. You can put all of those on top of it. But by default, this is not happening. So we're not understanding your sentences. Okay, let's do a quick example of putting some more advanced concepts together. So the first thing we have are synonyms. So for example, here I'm defining that father and dad are just the same thing. So if I'm having father and I want to search for dad, I want to find the same position. And then I say I have droids, and I assume that droids are replaced by droid and machine, because the assumption is every droid is a machine, but not every machine is a droid. I hope that kind of makes sense. And then we use our analyzer that we have seen before, and at the end we apply our synonyms. And then I store that in a field called myAnalyzer, and I just have a field of the type text, which I call quote, and I use that analyzer. This is pretty much like the schema that you have in a relational database. We just call this mapping, and this defines how stuff is actually stored. You could then define, this is a number, like this is a float, a long, in whatever. This is text, and will run through this analysis pipeline. So I can store that, I can throw 3 documents into that, like the 3 that you have already seen. And then you can just retrieve stuff as you would do in a relational database, for example. So here you can see we have our sentence and just some metadata around. If I just add source, this is pretty much what a relational database would give you. You can just retrieve a result directly. We can do that, but that's not really the full power of full text search. Let's run some proper queries. What will be the SQL equivalent of this query, for example? Query match all. Any guesses? It's pretty much a select star from Star Wars, since we're in the Star Wars index here. So if I run that, I get my 3 documents back. That's pretty much what I would expect. If I search for droid, how many documents will I get back? How many of the 3 contain droid? It was just 1. These are not the droids you're looking for. Would I find something if I search for droids in the plural? Will that make a difference? No, I will find the same thing because we have stored the text with an analyzer, and it will run through the same analyzer for the search terms. So that search term would also be stamped down. So then you would get droid from that as well, and then you could have a direct match on the droid from the tokens that you have extracted from your sentence. And that's what it makes it so performant, because you just have direct matches, basically. If I search for dad, would I find anything? We didn't have dad anywhere, did we? We did in the synonyms. So if I search for dad, it will find that. And it will just be exactly the same as if I was searching for father. So this is how synonyms work. It's just really searching basically for both of them, and then finding the places where we have them here. We can also do a phrase search, for example, where I say, I am your father. And then obviously we would only find one document with exactly all these tokens in exactly that order. I am your father. You could also do something like you can have a slop factor, which basically you can have one token in between that is in the search result, but not in your search query. And it would find, I am not your father. It would find that, but it would not find, if I say, I am your loving father, it wouldn't find that. Because everything that is here in the search query needs to be in the found document. It can only miss something that is in the found document. Why did the previous query work? Why did this one work? Because the not is a stop word. So basically that would remove the not from the search term already, and then we would have all the tokens that we're searching for, we would have in the result as well. So stop words will always come back to you if you forget which ones they are. We also have a very nice concept about fuzziness. So for example, if I forget how to spell Obi-Wan and I spell it with a V, we could just say like, this should be fuzzy. And fuzzy basically means there can be a misspelling. This is a Levenstein distance, so you can have one. In that example, it would be the same as if I had a fuzziness of 1. So one letter too much, missing, or one letter different. Depending on how long that word is, the auto fuzziness would give you a fuzziness of 0, 1, or 2. And, well, you can find that. Now, if I search for Obi-Wan and I misspell both words and I have a fuzziness of 1, would I find anything? Well, I have to disappoint you, we do. Why? Because Obi-Wan, in the standard tokenizer, the dash is broken up into 2 tokens, and the fuzziness is on a per token level. But that's kind of a trick in here. That's something you just need to know. Okay, so one other thing that we have seen here is this score. This is the final thing I want to kind of explain, like where does this score come from? This is basically the relevancy. How well does this document match the query that I've sent? And how to order them. It's not just like I said, databases are black and white, yes and no. This is much about the quality of how good does your search document fit the query that you have been running. So if I go down to the score, what we generally have is it's called TF-IDF, term frequency inverse document frequency. That's the algorithm how we calculate that. Or that was the old one. By now we have replaced it by something called BM25, which stands for best match 25. It's the 25th iteration of the best match algorithm. Maybe we'll have a BM30 at some point as well, which slightly tunes some parameters. But what it generally does is it has 3 main parts for searching. And those are, the first one is term frequency, which basically means you're searching for father, and one document contains father once, and another document contains father 3 times. The document that contains father 3 times is more relevant than the other one. Kind of intuitive, I guess. And the curves look something like this. So this is like how many times does your search term appear and how relevant it is. And you can see it appears 5 times, it's much more relevant than if it appears once. And you can also see TF-IDF kept growing, like 20 times is more important than 10 times. BM25 assumes, well, once you hit like 5 or 6 occurrences, it doesn't change much anymore. This is just how we assume that it works out here. The second thing is the inverse document frequency. So we assume over all the documents that we have, how common is a term. And it basically assumes the less common a term is, the more valuable it is, because it's very rare. And it looks something like this. Over all the documents, your search term father appears 100 times, then it's very relevant. If it appears hundreds of times or 1,000 times, then it's not so relevant anymore. That's the general idea. And the final one is how many tokens do you have in your document? Which is pretty much like you have the subject, which is short. If you have something in a short text and you have a match there, it's more relevant than in a very long text. I guess that's also kind of intuitive. That's how we calculate that. So for example, if I run that on father and I search for father, you can, if you have this add this explain, it will basically tell you these are all the parts and these are all the calculations. But this is what Lucene is actually doing in the background for you. With explain, you can actually debug and see like why is something more relevant than something else. And if I search for father, these are my two documents, and one is slightly more relevant than the other one. Why is the first one more relevant than the other one? It's just the length, the number of tokens, because the term frequency is the same. Both contain father once. The inverse document frequency is also the same because it's father for both of them and it appears twice over all the documents. It's just the first one has 4 tokens and the other one has more because I cannot count. But this is why the first one is, you can see it's slightly more relevant than the other one. This was always true when you search for one token. What happens if you search for multiple ones? This is actually tricky. Assume you search for your father. Obviously, the perfect document would contain your and father. But which one is more relevant? A document that just contains your or just father? That's kind of tricky how to figure out which one is more relevant. This is like vector space model is depending on how many terms you have, that many dimensions you will have. If we have 2 terms, it will be a 2-dimensional problem. That's why we stick to 2-dimensional here. And you can see, I assume that your is very common, so it's not that valuable, whereas father is not that common, so it's much more valuable. And the perfect document would be that vector that goes to your father. And then to calculate which document is more important, one that only contains father or only that contains your, we basically draw those vectors as well and then calculate the angle. And the smaller the angle, the more relevant the document is. So you would have first a document with your father, then the documents just with father, and only then all the documents with your. And if you have 5 dimensions, this would be 5-dimensional, and I have no idea how that should look, but you get the idea. You can also reward, like if you have more terms matching, if you search, for example, for 3 terms, we're not just adding the scores, but we're also multiplying it by 1 divided by the number of terms that we have in there to make that coordination better. And then you can put it all together, and this is basically what is the calculation in the background. It looks complicated, but you've seen all the parts, so there should not be any surprises in there. You can also make that scriptable, like you can do your own if you need any custom functions. For example, what you could do is you could just randomly score to get a random result back. When might that come in handy? For example, to get back a sample, you have a very large document of bodies and you want to have like 10 random documents. So you could use the random function. And the final thing is, because I see people try that every now and then, and it's a very bad idea, is we want to take this score and say this is a percentage. Like this is a 100% perfect match. And this just does not work. The documentation is also very clear about that. Stop trying to think about it that way, because it just does not work. And just to give you very quickly the final example of why this is the case is, let's say, these are my father's machines. This is a sentence we store. And then, this is what we basically keep in there. And then, so we store that, and then we search for my father's machine. These are all the 3 tokens that are kept when you store those. And then, that will give you a score of 2.9 something. If you search for that, you could assume, well, this is a 100% match, this is perfect. The problem is, if you remove that document then, if you remove that document, and then you search again, then you would suddenly only have a smaller score. And would that now be a new 100%? Or would that be more like a 43% match? So that doesn't make any sense. And then what happens if you add another sentence like, these droids are my father's machines, and you can see father appears twice, and with the synonym machine and droid appears twice, and you remember the term frequency, because of that it will be more relevant. If you search for that, you will suddenly have something that is 3, and then you would have a 103% match. So just don't do that. It's not going to work out well. Just don't think about it in percentages. We've seen how to store stuff. We've looked at some very simple search functions, but search can get much more complicated. if you don't want to fight all the complexity in there, we have something now, the beta was recently released of App Search, which basically does that for you and gives you a UI. And rather than having to wrangle with the REST API, you can just put your synonyms and how to rank stuff through a UI. And you also have like the track back of how queries are performing. So we have like more of a solution that you can also use for that. And next up, Piotr will show you how to do stuff with machine learning, I think. And we need to quickly switch that over again.
Yeah, perfect. So, hello guys, I'm Piotr Kobrzakowski, so I'm a solution architect at Elastic, and I will briefly talk about machine learning at the Elastic and what we do with machine learning on our platform. So first of all, when you think about machine learning is really, really broad topic. It covers deep learning, support vector machines, supervised machine learning, unsupervised, and so on. And we are actually focused on a very narrow subset of machine learning. So we are focused on unsupervised section and also anomaly detection. So we try to find things which are differing from normal. So I'll try to go for the definitions and then to let you understand what kind of things we can find in data using our machine learning. And then I will follow up that with short demos. For each use case, you'll see how to do it in Elastic. So first of all, we need to define what's normal. So we can define normal in two different ways. So one is normal, so that means that this is consistent behavior for one single entity when you look at its past behavior. And the other one is behavior of the same entity in comparison to whole the population of other entities. So when those differ, that will be abnormal behavior. So when something changes behavior like you see here, that's anomaly. So humans can see that kind of things very easily. And till now, we've got only thresholds which we were setting, which helped us to actually understand that something is different and changes. And maybe we should look at that. So in terms of, for example, alerting on or finding things which are not working properly. But when you think about something more complicated, that for example, this metric will change over time. It will be growing steadily. So for example, number of users of the systems will be growing. It will be more users. Then thresholds will no longer work. So our machine learning jobs will learn the past behaviors, and then they will try to see how the new behaviors, new values should be looking like. So it will look at the piece of data which is the base actually for calculation, the baseline and the behavior. Then it will find that something is different than the previous data is so, and then it will be again normal. So then we have another example of the population differences. So this is normal. So we actually can group those quite easily with our algorithms, and then see that another part of our data is different from all this population. But we also enable users to see something somewhat anomalous. So we actually are scoring all the results from 0 to 100, and then you can actually see a gradual change in the anomaly score. So in summary, anomalies are basically significant changes in the behavior. So this is a EKG signal from the heart rate, and then we can easily find things like that. So we can actually apply that to medical cases. And then the second thing, which we didn't mention before, is when the values or something or one entity is entirely different from other entities. So that can be applied for any type of data. So it can be name, it can be IP address, it can be gene in DNA sequencing, it can be tagged picture with metadata, and so on and so on. So what is our product philosophy? So we try to learn data, we try to predict values, then we try to find how the actual values from the data differ from our prediction, and then we try to operationalize it so we are able to bind it to the alerting feature, which is enabling user to integrate that to the external systems. That can be, for example, webhooks, that can be a messaging platform, and so on. So what are the most visible use cases to us? So when you look at, for example, operational analysis, so you have systems you run. So it can be financial observation. That can be, for example, IT system operations. So you have different metrics from the systems. When you look at these metrics, so normally you will need to set up thresholds, you'll need to set up rules for each particular behavior of your system, and then you'll have possibly quite many false positives. When you apply machine learning will automatically split data across entities. It will find different behaviors over time, and it will be able to flag it and also alert on it. So that's for much easier alerting in terms of systems observation. So it has really huge impact on the mean time to resolution, because when you actually can find anomaly within a particular period of time, then you can actually go quickly to this particular data and see what happened and why the data is showing you some problems. So then it will be shown like you can see on the slide. We can easily apply this kind of solution to security space. So you can easily find the malicious behaviors, or let's say at least suspicious behaviors, when somebody is logging, for example, to the machine in the office at time when he actually never did it, or if he's using different IP address he never used, or maybe your credit card is used in the country where you never traveled, or maybe amount of money spent is different, then you can actually find easily this with machine learning algorithms. And we can apply that also to more natural and close to human behaviors systems as well. So we can observe interactions, human interactions with the system. And then we can map behaviors. Like, for example, this is showing customer care calls after Elon Musk tweeted that he's taking Tesla private at $420. So, and then this all behavior was automatically mapped here and detected. So, product development. So, as you heard, Elastic is a pretty young company, but machine learning was developing even before Elastic started, because machine learning came with company Prelert. They started their machine learning development very early. So those are the algorithms. Probably it's not so visible, but there are many algorithms, not single, which are helping us to do that. So basically, machine learning, in few other words, is automation in terms of selecting proper model for the data, and this based on this selection, then and then applying proper model, we find anomalies. So now I will quickly switch to demo. I will show you how easy it is to create machine learning jobs. So first of all, I have some data loaded here. So data is showing system which is used for booking airline tickets. And first of all, we have a number of requests from customers here shown over day and night. So we have the lower and higher request rates. And then we have that split it per airline name. Here we have different response times for the system. So we see that one is kind of outlier here, then the rest are pretty much similar. So they have much shorter response times. And this is overall how number of requests are looking over time. So to create the machine learning jobs, we need to go to machine learning section. We select create job. We select index. So index, I don't know how many of you are actually already knowing what the index. Index is storing data. Is like the closest comparison to database. It will be like a table. So we choose one of the indexes. So that will be third quote. That will be the index we are looking at. And now we see a number of different types of analysis. So we have single metric, which will be able to actually show you behavior for one single metric. So in our case, we'll do single metric for all the requests which are coming to our system, and then we'll see how quickly we can see changes here. And then we have multi-metric. It is showing you the data split across all the entities, and it will show you misbehaving in comparison to the previous behaviors of particular entity. population, which will enable you to see how different is, in this case, response time from one of the airlines to all the others. And that will be all automated without defining anything in the programming way. So single metric, I'm choosing count, and I see this is the count of the events coming to the system. And we would like to see, so humans obviously can see that very quickly and easily, and in our case, we just need to select data we are interested in. We put a name for the task. I will call it task 1, and then we create job. So now machine learning will learn behavior, so it will create the baseline. So the this blue color here, bright blue color, is showing the baseline. So what is the baseline? Baseline is the highest probability, looking at the probability distribution, where the values can actually be. So this is accepted probability levels. So when the values are here, we are not saying this is anomaly. When this goes beyond baseline, so like we see here, this will be marked automatically as anomaly. So we can go to the results review, and then we see that this is marked already as anomaly. We have description, and this is what I mentioned before. We have mapping for severity level. So that means how anomalous this particular value is in comparison to the previous observed behaviors. We see how much different that is. And then we can also tweak particular machine learning job with, we can create rules when we would like to discard particular anomalies. So when we actually think that we should not see anomalies below, let's say 50, then we are able to do that. And then what is actually anomaly 50? So anomaly severity is a mapping from the, maybe I'll make it a little bigger. It's a mapping from the probability to human readable numbers, because obviously probabilities in every single data set will be different, so we'll be not able to judge if this is big anomaly or small anomaly. So we normalize this result and we show from 0 to 100, and then this is clearly visible if this is anomaly or not. So this is how we find on single metric. Then let's see how we can do that on multi-metric. So I will just choose the same. So I have fur quote, I will do multi-metric, and now we have a little bit more complicated UI. So we choose, for example, response time. We use full set of data. We split this data by airline keyword, and now we have all these airlines analyzed separately. And then we create job the same way. So we put test 2, and then we do analysis. So analysis is finished now, and then we can review the results. But results will be actually shown a little bit different, a different way. So this is showing how the data is actually processed. The previous one was showing that on the time series data. Here we have that shown in time series, but aggregated to the bucket spans. Bucket spans are the time buckets in which we do calculation for our functions. So we can apply multiple different functions. Here we just counted the amount of, so we looked at the response times, and then we see which airlines are actually which airlines are actually infected the most with the longer response times. So we have something which is called influencer. Influencer is telling us which value or which field is present during anomaly. So we can quickly map it to IP address. I'll show you later on security application for machine learning. And then here we have the list of all anomalies, and the same like previously, we'll be able to see which is the most anomalies, and we can make sense of it and connect this to alerting. So the last two will be population analysis. So we take the same data set, we choose population will be airline, and then we'll look at the field. Yeah, okay, so we'll just create like this. And then we'll see what's different in the data here. I just forgot to click useful data. So once again. Okay, so now we'll be looking what's different, which airline is behaving differently than the rest, and again we see the results. So we found out that one airline here, NKS, is way different from all the others. So when we look at the single metric viewer, let me see that, yeah, single metric viewer, let's click on maybe this. So we see that it's standing out from the crowd and it's way different than all the other values. So the last example will be for logging. We can put any type of data, textual data, to our system as text file. We can upload this file by dragging and dropping. So I have actually here logs from one of the machines, SSH logs. We can put that for analysis. It will automatically create pattern for this analysis. Here we have timestamp and other things which you can also override. Then we have summary, and then we can import that data to our system. So we'll put import it, so now data is imported. And then what the system will be able to do, it will be able to create, cluster particular events and see that particular logs are appearing more than previously. So it will be able to detect, for example, application failures, application misbehaviors in a very automated way. So we create machine learning job. Then we go to advanced function, put test 6, analysis configuration. So that will be a little bit different configuration. So we need to use categorization field name. So this is describing the field which will be used to categorize and match data. And then how this categorization will be done. So all the lines, text lines, will be split into the pieces, and then all the components which are the same will be kept for the categorization, and everything which differs, like usernames, dates, IP addresses, all these kind of things will be automatically removed, and those will be bound together and counted, and you will be able to see how this, what will be the result of that. So function will be count, the function and the field will be ML category, and then we save the job. We'll start data feed. And then we'll see just in a few seconds when it's refreshed. Okay, so we have logs here, and then we can see how these logs were grouped together. So system automatically picked the logs in red, actually the time when logs started to appear differently than before. We can look quickly what happens here. We can expand, and we see that these logs are detected to be different, and we have a typical number of occurrences 0, 0, 1 per this particular period of time. We see now 3 of them, and basically we are enabled to find these small things. So then I'll quickly jump to different. How much time we have? Okay. So just quickly on the quick story on the real use case. So we have a system which is looking like that. So we have a number of machines. All these machines are having bits component installed. So it captures data from the system. It does some enrichment on Logstash, and then it's fed to Elasticsearch. And we would like to find different anomalies across our computers to find malicious behaviors and find threats to our network. So we start from DNS exfiltration alert. So DNS exfiltration is actually the process of transferring data within DNS queries. So it is possible to encode user packets into DNS subdomains and then, for example, steal data out from the organization. So we would like to actually find quickly this kind of behaviors, because there are no firewalls actually which can protect against this. So there must be much more sophisticated solutions. So Elastic can help with that as well. So we got email address. So this is what you saw before, and with a link where I clicked. Actually, that was automated email from machine learning job. It told us that it noticed strange behavior for one of the domains, that the number of requests from the domains and subdomain cardinality is much higher than normal. So we see that this domain is listed here as an influencer. We see also that at this period of time we have this kind of problem. We also see influencer, which is server here. And then we would like actually to see what happened and where. So we can click on this particular time, and then we expand and we read what happens here. So Elastic also enables you to link dashboards. So the dashboard describing that will be dashboards related to the server itself. So you can find any type of visualization linked to particular observation, and we quickly see what happened here on the server. So we can notice that here we have loads of failed login attempts. We see that these logins are happening from multiple different places in the world. We see that some of them are malicious. So then we quickly found out that something happened to the server. Somebody logged at this period of time, and he started DNS exfiltration process. Maybe he was actually stealing whole database through DNS traffic. So I think that will be all for now, and we'll switch to another presentation. Thank you.
Thanks, Piotr. Very interesting. I love how user-friendly it is to set up those rules. Okay, in a moment we have Richard, but just first up I'd just like to introduce David, who's the CEO of Data Practitioners. David, just stand up for a moment, please. So David is over from London tonight, guys. So via Data Practitioners, David is advising and helping many companies in London on their data journey and helping them with the challenges of their face in data. So providing solutions on Elasticsearch and other technologies like Pivotar, Tamar. So please feel free to go and have a chat to David and learn from experiences this evening. He'll be around at the bar, no doubt, enjoying a good beer. Next up, guys, we got Richard. Richard is the head of a commercial at Data Practitioners. So Richard brings his experience from Google. He worked in Cambridge Analytics, which some of you might have heard the name, more recently. And more recently, he's now with Data Practitioners. And he's helped build a product around client engagement using artificial intelligence and behavioral science to help companies target clients more efficiently. So I'll give it up for Richard.
Thank you very much, Ken. It's an absolute pleasure to be here tonight. How are we all feeling? We've all been sat down in the dark for a little while. Are we all still with us? Yeah? All still concentrating? Somebody's nodding their head, so that's fine. So I realise that I am the only thing that is between you and grabbing another beer. So I'm going to make this quite quick. So what I want to talk about is what we at Data Practitioners are doing, building on Elastic. We're very much focused around helping marketing in particular. We found a particular business challenge in marketing. So we're very much focused around helping marketing and marketers better engage with their customers. And one of the key things that's important for marketing today is the use of data. Hence the reason why it's so important that we're working with Elastic and the way that that technology is actually empowering what we do. So So maybe to start, can I ask you, if you are in marketing or anything to do with marketing, can you put your hand up now? Oh, damn, I was hoping nobody here would know anything about marketing, so thank you. So I better tell you the truth rather than just making it up. So let me start by a truth that I see today in marketing, and that is that my clicker doesn't work, or I'm holding it the wrong way. And that is that there's a fundamental challenge that PowerPoint doesn't work. There's a fundamental challenge where today marketers are really struggling to understand you and me as consumers. Why is that? Well, there's a whole different way that consumers are engaging with brands. But there's a real element that marketing needs to understand, and that is to truly engage with a customer, you need to understand them. You need to understand them through the data that you've got. You need to understand them through the data that you're collecting on an ongoing basis. And you need to understand them as individuals. And in that respect, we call that behavior or behavioral science. And so this is very true, what we feel today. The saviour of marketing is simple, and that's around knowing your customers. And that's what we at data practitioners are trying to do. Our simple goal is to help marketing use data to better engage with their customers. And we do it through several mechanisms and uniquely bringing together data science and behavioral science to develop data-driven creative approach that means that brands can engage with their customers in a far more engaging and profitable way. We do this to solve specific business challenges, such as who are my best customers, how can I find more highly profitable customers, and how can I ensure that those customers stay with me over time rather than churning or leaving to other brands. There's 3 pillars of how we do this, and with all data, it's all about the quality of data and how to use that data. So we use three types of initiatives. The first one is around behaviour or behavioural science. And this isn't necessarily about how people act online and what websites they go to, but it's about understanding individuals as individuals. It's what makes them tick, what motivates them to make a decision that they're going to make. We then combine that with data science, so actually using large sets of data and understanding and predicting what series of behaviours are going to, and data points are going to help us predict who is more likely to buy a product or who is less likely to buy it. And then the third key area where we're using data in marketing is very much around creative and creative development. No longer today does marketing work if you have one message and you shout that to everybody. What you need to do is you need to have very bespoke messages, personalised content, aimed at small groups of people or down to individual level to really drive the most out of those engagements with those customers. So how are we doing this? Well, we're really passionate about the way that technology is moving from a process of enabling marketing and moving into a situation where it's empowering marketing. And that's what we're trying to do here. We're trying to automate as much of this process as possible. And that, again, is very much helped by the Elastic Stack. And what do we mean by that? Well, today, I'm a marketer, and I've got multiple sources of data. That might be from my customer relationship management system, might be from my web analytics, it may well be from my point of sale data. And today, brands are finding it really difficult to consolidate that. So we're helping them bring that data together. We're then overlaying that with, as I said, behavioral insights and enriching that to put that through our analytics engine and running very specific algorithms and running machine learning to answer those very focused questions such as how do I find more customers, who are my best customers, and how do I reduce churn. And from that, that's really interesting, and other companies kind of do that. What we do is we then extract that data and the insights out of that and make it actionable within the platform. What do I mean? Well, we're able to provide real advice on about who to talk to, with what message, in what tone of voice, on what platform. So you can suddenly start to really segment your audiences down and be able to engage with them on a one-to-one, one-to-few method that really enables and empowers you to get a better result out of what you're doing with them. Let me bring some of this to life a little bit. No, I'm not going to do a product demo. I think we've covered the product demos today. So let's have a look initially at the kind of data side. So what kind of data can we use and do we use? Well, we often start, as I said, with customers' first-party data. That's the CRM data, point-of-sale data, that sort of thing. We then go outside and look at what third-party data is available. So this is the kind of data that you can buy from third-party data providers that suddenly enables you to enrich that data slightly. So if I bring this to a point, an example. So for example, I might be your customer. You'll know how many times I've bought from you, what I've bought from you, how many times I've visited your website. So quite detailed information, but it's very narrow. Third-party data helps you expand that out to understand that, okay, you know who I am, you know where I live, and those things, and suddenly you understand, well, this is the kind of house that I've got, this is the kind of car that I drive, these are kind of the interests that I have outside of my engagement with your brand. And then the final piece that we do is very much around understanding people as individuals. So this is behavioral science. We've got an in-house behavioral science team that really look to try and understand what are those triggers that make David, for example, buy something different to me. What are the ways that you can nudge somebody along a purchase process to get them to do the action that you're primarily looking for? I'd like to use a real-life example. Those at the back won't be able to see the photographs on here, so I'll describe it. On the left-hand, your left-hand side, there's an old bloke. His name's JP. On the right-hand side is a very young, attractive man. Okay, well, that photo was taken a long time ago. That is me. And why have I put this up here? Well, JP and myself are basically in the same age group. We work in the same sector. We live in relatively similar location. We're both university educated, and we're both very, very keen cyclists and oarsmen as well. So in traditional segmentation, marketing segmentation approach, you would put us in the same bucket and you would serve us the same message, trying to sell us the same product. The value that we add to this is, in fact, what you see is that we are very different people. So JP, on the left-hand side again, takes very risky financial decisions. He's also a high adventure seeker, and he's very, very passionate about thought leadership and likes to be in inspiring company and driving conversation. Broadly, I would say he's quite an extrovert. As an example, for a holiday, JP will go, 2 years ago, went on holiday to the Antarctic and climbed a mountain. Now, let's move over to me for a second. I score very low on or very stable on our shop stability index. That means I don't go and spend money too rashly. I've lived in my own property for a very long time. I even actually buy a lot of books. And when it comes to holidays, I don't go climbing mountains in Antarctica. I actually rent a villa in the south of France and just sit by the beach. So from that, you can start to understand that we're actually very, very different individuals. And why is that important? Well, by understanding we're different individuals, you can start to message to us in different ways. And again, this is all within our platform. We take the insights and we start to develop what's the tone of message and what's the imagery that you need to be to engage with somebody like JP. So in this case, you need to appeal to his highly extrovert nature. You need to use language that encourages experience and performance, cutting-edge design. And so hence the reason why if you were Volkswagen, you'd probably serve him an ad about their high-performance Golf R. It'll show it going around a racetrack or driving around a bend very quickly. So putting him in the experience and having very strong calls to action, book a test drive today. On the other side, if you wanted to sell me a Volkswagen, tell me where the rear parking sensors are, how many airbags does it have, and can I fit my dog in the back? So again, understanding your customer, understanding your consumer, and tailoring those messages to meet them in the right way. So once you've got that again in the platform, it's able to build this and provide this insight, then make it actionable. And our platform will help do that by simply taking the segments, the data out of that, matching it into advertising technology platforms, and then allowing you to go and reach those people with the messages that are of most importance and the highest impact. And of course, the data is looping back around, so coming back into the analytics, so it's improving on an ongoing basis. So, just finally, I'd like to just talk a little bit about a case study that we have from a customer. This is a UK-based luxury retailer in the perfume sector. They basically didn't really understand who their customers were. They had a certain amount of customer data, and although sales were growing, it was quite organic. There was no real acceleration in growth of sales. So we went in and helped them by bringing their data into the platform, running algorithms over the top of that to understand who their customers were today. We went out and collected more data, the behavioral insights on that, overlaid that over their existing customer data, and were able to identify segments in the market that they were not tapping into that had a high sale opportunity for them. We then took those insights and worked on developing specific creative messages around that, so very distinct messages for those different segments of groups. And the results were quite outstanding. So over the Cyber Week, Black Friday, Cyber Monday weekend, we drove additional sales of 68% year on year. We drove cost per acquisition, so the cost it was to acquire those customers, we managed to reduce that by 45%. And so over 60% of those customers coming to them that we were brought to them were brand new customers to them, so net new. So driving significant investments through the use of data and behavioral science, driving very, very targeted messaging. As I said, we've got a platform that is working on this. The engine underneath that is Elastic, and it's really helping us really empower what we're trying to do and bring those messages and that advancement to marketing. That's it, short and sweet. Hopefully that was of use. If you're interested in chatting, the one marketer in the room, if you'd like to chat afterwards, I'm here and I will also be at the bar. Thank you very much indeed for your attention.
Great, thank you, Richard. Okay, guys, we're going to take a short break for about 15 minutes. There's plenty of beer, plenty of food, so please help yourselves. And as Paul said earlier, this is a community, all about collaboration. Go and talk to some new people. You never know who you meet and never know what you'd learn. Talk to you shortly, yeah? Thank you, guys.
Seven.